The internet as we know it is about to change forever. Here is how quantum internet could transform your life first. The internet is about to get a mind-blowing upgrade, one that could make hacking a thing of the past. In 2025, scientists pulled off something wild, transmitting quantum data across real-world fiber optic cables. This is not just about faster speeds, it is about creating an internet that is virtually unbreakable. But what will quantum internet actually change first, and how soon could it impact your money, your data, and your job? Let us break down the future before it arrives at your doorstep. Subscribe to Smart AI Hustle for weekly AI playbooks you can use today. Here's the twist: most people skip the key quantum internet step. In 10 minutes, I will show the proof and the fix. Most people think the internet is fast pipes and cloud magic, but underneath it runs on math that can be predicted if you have enough time and power. That is the problem. Classical encryption depends on hard problems that future computers may solve faster than we expect. The quantum internet flips the game by turning the laws of physics into the lock and the alarm system. If you try to copy quantum information, you disturb it, and that disturbance is detectable. That means the first impact will not be consumer speed, it will be trust. The earliest wins arrive where trust is worth the most. So what changes first? High-value links between places that must never leak secrets. Think bank data center to bank data center, hospital to research lab, stock exchange to clearinghouse, utility control rooms, election systems, and government networks. These are the arteries of the economy. They move money, records, and commands. The first deployments of quantum internet will wrap these arteries with quantum keys that are generated and refreshed using light, randomness, and physics itself. You will not see it on your phone at first, but you will feel it when transactions fail less. Breaches drop, and approvals happen faster with lower fraud. Here is the proof in the path. Quantum key distribution, or QKD, already demonstrates that two sites can create shared secret keys by sending photons over fiber. If an attacker taps the line, error rates spike, the system knows, and keys are thrown away. The fix for distance is a series of trusted nodes, and later, true quantum repeaters that keep entanglement alive over long spans. Early citywide pilots and cross-campus links show this is not science fiction. It is an engineering rollout, just like the early days of fiber backbones and 4G towers. The big shift is mindset. Security moves from math hardness to physics tamper evidence. Now let us map how this touches your money, your data, and your job. Money first. Payment networks and interbank transfers depend on keys that must stay secret. Quantum-secured channels make key theft dramatically harder and slash the window for man-in-the-middle attacks. That means fewer freezes, fewer false positives, and faster clears for high-value transactions. You may not notice a new app icon, but you will notice fewer calls from the bank asking to verify a weird login. For traders and fintech teams, quantum links between matching engines and risk systems reduce the chance that critical messages are spoofed or delayed. Data next. Health records, legal contracts, and confidential R&D move across private lines that still touch public infrastructure. Expect hospitals to link surgical centers and imaging labs with quantum-protected keys long before consumers get a quantum modem. For startups that handle sensitive data, early access providers will sell quantum-secured interconnects between your cloud zones and your on-premises vault. That means audit logs that matter and breach postmortems that do not end with "we think someone sat on the line for months." Your job, if you build software, security and networking will feel different. Key management and rotation will start referencing quantum-generated keys. DevSecOps will add quantum-safe ciphers on the classical side, and QKD integrations on the transport side. If you work in compliance, vendor questionnaires will begin to ask about quantum readiness and incident response under quantum tampering. If you are in data, you will see pipelines mark certain hops as quantum protected and others as classical, with rules that adjust what can flow over each. If you are in creative or marketing, the near-term change is more subtle, but real. Trust badges and procurement standards will favor vendors who can prove tamper evidence on sensitive flows. That raises a fair question. If quantum internet is coming, what about post-quantum cryptography? The answer is both, not either. Post-quantum cryptography gives us new classical algorithms that resist quantum attacks and run on today's hardware. QKD and quantum links add physics-level tamper detection for the highest-stakes routes. The near-term blueprint is hybrid. Migrate your software stacks to post-quantum algorithms while critical backbones adopt QKD, where the cost and complexity are justified. Over time, as quantum repeaters mature, more links join the quantum fabric. Let us get concrete. Use cases that flip on first. Bank data center interconnects because the value per bit is enormous. Cloud region backbones that move customer keys and control plane traffic, health networks that route live surgery video and robotic commands, identity providers syncing route keys between continents, satellite ground stations relaying time and navigation references. Even content delivery networks may start signing and refreshing edge secrets over quantum channels to make large-scale key theft far harder. Each of these is invisible to consumers, but visible in the metrics that matter to operators. Fewer incidents, shorter breach scopes, and faster recovery when anomalies are detected. What about distance limits and cost? Early rollouts will ride existing dark fiber between short hops, then daisy chain through trusted nodes. That is imperfect but still valuable because tapping anywhere in the chain increases detectable errors. As quantum repeaters arrive, trusted nodes shrink and paths get cleaner. Costs follow the usual curve. First it is labs and telecoms, then enterprise pilots, then managed services you can rent by the hour. If you are a builder, that is your opening. Tools that observe error rates, manage key life cycles, and simulate failover policies across mixed classical and quantum paths will be in demand. If this helped, hit subscribe and watch the full breakdown next. Now, how do you prepare without buying a lab? Step 1. Make a quantum readiness map. List your highest value links, the data they carry, and who has to trust them. Mark which parts you control and which live in a provider backbone. Step 2. Move your software to post-quantum cryptography as standards settle, starting with backups, archives, and systems that must remain safe for years. Step 3. Harden key management. Shorter key lifetimes, strict rotation policies, hardware roots of trust, and verifiable logs. Step 4. Talk to your providers about QKD roadmaps. You are not asking for hype. You are asking how and when they will offer quantum-secured interconnects between your most sensitive sites. Step 5. Build habits that make the shift smoother. Classify data by sensitivity, not only by application. Add simple checks for tamper evidence and monitoring. Teach your team the difference between encryption strength and tamper detection. Let us close the biggest loop. What will change first in daily life? Most people will not notice a new device. They will notice that high-value actions feel smoother and safer. Fewer fraud scares. Less friction when moving money across borders, medical portals that do not log you out mid-session because a risk engine panicked, contracts signed and countersigned faster because the channel they travel on is harder to spoof. These are small moments that add up to trust, and trust compounds. Here's a second loop. Will quantum internet kill passwords? Not directly. It makes the channels that move keys and approvals far harder to tamper with. On top of that, better authentication flows and passkeys reduce the burden on users. The right mental model is a braid. Physics-level tamper evidence in the transport, strong algorithms in the software, and human-friendly authentication at the edge. Together, they reduce the attack surface in layers. A third loop. Where are the jobs? If you are technical, watch for roles in provider networks, secure interconnect teams, and key management. If you are a consultant, productize a quantum readiness assessment for regulated clients. If you are in content or education, translate this into simple stories that leaders can act on. If you are a founder, the picks and shovels are in monitoring, audit, training, and migration tools that make hybrid classical plus quantum networks observable and safe. We should also be honest about limits. Quantum links do not stop phishing or insider mistakes. They do not fix a bad process or a weak permission model. They raise the floor by making silent wiretaps far harder and by turning tamper attempts into alarms. You still need clean architecture, least privilege access, and teams who practice response. Think of quantum internet as a new layer that gives you sharper signals and safer key exchange. It multiplies the value of the basics, it does not replace them. So, what happens next? Over the next waves, backbone providers will light up more quantum test beds between data centers. Large banks, exchanges, and hospitals will pilot managed QKD. Standards will firm up around hybrid key exchange and logging formats that record tamper evidence. Then the toolchains will mature, prices will drop, and the language of quantum security will show up in contracts and procurement. When that happens, the winners will be the teams who already mapped their critical flows and practiced migrations on low-risk systems first. Here is your action plan this week. Audit one workflow that would be costly if tampered with and write down the exact systems and links it uses. Swap one component to a post-quantum algorithm in a dev environment and measure the performance hit. Draft a 2-page quantum readiness memo for leadership that states what you control, what your providers control, and one question you will ask each vendor about their roadmap. Finally, Teach your team the one-sentence explanation you can use with non-technical stakeholders. Quantum Internet turns physics into your alarm system. If someone tries to copy the keys on the wire itself tells you. Before we wrap, remember the simple pattern. Technology shifts first where the value per bit is highest. The quantum internet will start in the back rooms that move money, health, and state. You will feel its arrival not as a flashy app, but as a calmer experience where the critical things just work, and attacks ring bells instead of slipping by. Subscribe, then tap the end screen to watch the full breakdown.